Okay, hello everyone. We're going to talk about states of matter. This is the introduction to our next unit, which is gases and states of matter. Um, and so we can get started on that now. So the first concept that we need to make sure everybody understands is this idea of kinetic energy. We're going to talk about kinetic energy, particularly with respect to gases. Kinetic energy just means movement. Um, so anything that's moving has kinetic energy, and the faster it moves or the more that something moves, the more kinetic energy it has. The slower it is or the less it's moving, the less kinetic energy it has. Kinetic energy is just one kind of energy, and then when you get around to taking physics, you'll learn there are other types of energy as well, um, but the one that we're concerned about here is kinetic energy, which is the energy of movement. All right, and around this idea of kinetic energy, that we've developed a kinetic theory. And the kinetic theory, at least with respect to how it impacts chemistry, is that tiny particles, so atoms, molecules, ions, in any form, all forms of matter, any form of matter, the particles are in constant motion. All right, so let's talk first about gases, because that's kind of where we're going to start with our states of matter ideas. Gases are compressible, and you know this if you think about it, because you pump air into your car tire, and it's not like you can only put in a certain amount of air and then it stops. If you continue to pump air, the pressure inside the tire increases, but you're still putting more air inside. That's because the gas inside is compressing. So you can fit a variable amount of gas into a given container. That's kind of what we're talking about here. The gas can be compressed to fit into a container. Gas particles experience constant random movement. This is their kinetic energy. All right, we just mentioned a second ago. This is really Newton's second law. Not super relevant right now, but it's there, so we move it on. The collision. So you want to imagine gas particles. You want to picture them in your head as tiny little billiard balls rolling around on a billiard table. And when they bang into each other or they bang into the sides of the container, the collisions are elastic. Those collisions, those banging into one another, is elastic, which means that momentum is not lost. Now, this is an assumption, which makes, these are the underlying assumptions of the kinetic theory. And so this is probably not perfectly true, but in order to make the theory work, this is one of the assumptions that we make, that the collisions between molecules don't transfer energy from one to another. They are elastic. And then for gases in particular, we can characterize them by pressure, volume, and temperature. So in order to fully characterize or fully explain the condition or the state of a gas, you have to know what its pressure is, what its volume is, and what its temperature is. We're going to see how those play out in the next lecture when we get to gas laws. All right, but for now, let's suffice to define it at this point that you need to know these things to talk about a gas. Since we haven't talked about pressure before, we need to talk about units for pressure, and that's what we have here. So the way we measure pressure for a gas is we actually, unfortunately, have a bunch of different units that we can measure it in. The same way you can measure distance with inches or feet or millimeters. We have different units for measuring gas pressure, and these are called the atmosphere, the millimeter of mercury, the Pascal, and the torr. Don't ask me why we need so many different ways to measure pressure. We just do. And this is the way you convert from one of those to another. So one atmosphere is defined as the pressure